Your smart home was supposed to save energy. Instead, it might be quietly adding hundreds of dollars to your electric bill every year. Most people never catch it because the waste happens while you're asleep, spread across dozens of devices that never actually turn off. I'm Chelsea Miller, and I've spent 3 years monitoring every outlet in my fully local smart home setup to figure out exactly where the power's going. What I found was eye-opening. You're listening to the Smart Home Setup Podcast. Quick note before we dive in. Everything you're hearing is researched, written, and verified by real humans on our team, but the voice you're listening to is AI-generated. We do this to keep episodes consistent and get them to you faster. Just wanted you to know. If you've been listening for a while, thank you. It genuinely matters that you're here. And if this is your first time tuning in, welcome. We publish new episodes every Monday, Wednesday, and Friday. Now, here's what we've got for you today. This Smart Home Energy Audit Checklist is for anyone running energy management systems who wants actual numbers instead of marketing promises. You'll need smart plugs with energy monitoring, local access to your automation controller like Home Assistant or Hubitat, and the willingness to confront some uncomfortable truths about devices you already own. Let's start with baseline infrastructure: hubs, controllers, and always-on network devices. These run around the clock by design, and their cumulative draw adds up faster than you'd expect. Zigbee and Z-Wave hubs typically draw 3 to 8 watts continuously. That's 26 to 70 kilowatt hours annually. If you're running multiple protocol hubs because you didn't plan for Matter 1.4 compatibility up front, you're multiplying that waste. Wi-Fi routers and mesh nodes are worse. Consumer mesh systems easily hit 15 to 30 watts for a 3-node setup. Thread border routers embedded in HomePods or Echo devices add another 2 to 4 watts each. If your Matter 1.4 migration left you with redundant border routers, unplug them. Home automation servers vary wildly. A Raspberry Pi 4 running Home Assistant draws roughly 3 to 5 watts idle, 6 to 8 watts under load. An old desktop PC repurposed as a server, 40 to 80 watts idle. I moved from a salvaged Dell tower to a dedicated Pi and recovered 300 kilowatt hours annually, about $45 in my region. Network-attached storage, if you're storing local security camera footage on a NAS, expect 15 to 40 watts depending on drive count and spin-down behavior. A 2-bay unit running continuously costs $15 to $30 annually in power alone. Smart displays and wall-mounted tablets are sneaky culprits. An Amazon Echo Show 10 draws 7 to 10 watts when idle with the screen on. A repurposed iPad mounted as a dashboard, 8 to 12 watts if it never sleeps. Multiply by the number of screens in your home. Security system base stations, even subscription-free systems like Ring Alarm or Abode, draw 2 to 5 watts continuously. Add cellular backup modules and you're at 6 to 8 watts. Over a year, that's more than 50 kilowatt hours per system. I found 6 always-on devices in my network closet alone: hub, router, 2 mesh nodes, NAS, and a forgotten Z-Wave USB stick plugged into a wall adapter. Combined draw, 48 watts. That's 420 kilowatt hours annually, or roughly $60. Before a single smart bulb turned on. Moving on to high-draw active devices, the obvious suspects. These are the devices you know consume power, but monitoring reveals how much more than expected. Smart thermostats themselves only draw 1 to 2 watts, negligible. The real audit question is whether your heating and cooling automations are actually saving energy, or are they triggering more frequent compressor cycles than a dumb programmable thermostat would. Check your HVAC runtime logs. If your smart schedule is less efficient than the old 68 degrees all day setting, you've automated yourself into higher bills. Smart water heaters face the same reality. Resistive heating is resistive heating, smart or not. A water heater draws 3,000 to 4,500 watts when heating. The value proposition is only an automation logic. If time of day is between 11 p.m. and 6 a.m. and electricity rate equals off-peak, then heat to 130 degrees, else heat to 110 degrees. Without time of use rate optimization, you're just adding standby consumption of 3 to 6 watts for no benefit. Smart plugs controlling space heaters or AC units don't change the fundamental physics. A 1500-watt space heater doesn't care if it's plugged into a Zigbee smart plug or a dumb outlet. But the plug itself adds half a watt to 2 watts of vampire draw. If you're using smart plugs to control devices that are already manually switched off, you're wasting power for theater. EV chargers with smart features can be wasteful. Level 2 chargers draw 30 to 50 watts in standby when no vehicle is connected. Some models, looking at you, older charge point home units, never fully sleep. If you charge twice a week, but the unit's energized around the clock, that's 260 to 440 kilowatt hours annually just maintaining the smart features, more than many households' entire lighting budget. Run your high-draw devices through smart plugs with energy monitoring for 2 weeks. Compare their actual consumption to the nameplate wattage. I found my 1500-watt oil heater averaged 940 watts due to thermostat cycling, but my 200-watt TV soundbar with HDMI pass-through drew 18 watts, even when off, 9 times the manufacturer's claimed standby figure. Now, let's talk about phantom loads and vampire draw, the silent budget drain. This is where the audit gets uncomfortable. Devices that appear off but never actually stop consuming power. Smart TVs and streaming devices are major offenders. A Samsung Frame TV draws half a watt in off mode, but 22 watts in ambient mode, which is the default. A Roku Ultra? 4 watts when off because it's listening for remote commands. An Apple TV 4K in sleep mode? 1.5 watts. None of this is disclosed clearly in marketing. Multiply by the number of screens in your home. Voice assistants and always listening devices add up fast. An Echo Dot draws 2 to 3 watts idle. An Echo Show 10 draws 7 to 10 watts. A HomePod Mini draws 1 to 2 watts. If you have 8 voice assistants scattered through a large home, and I'm guilty of this, that's 20 to 30 watts of continuous draw just to hear Alexa or Hey Siri. That's 175 to 260 kilowatt hours annually. I unplugged 4 of mine. Nothing changed except my power bill. Security cameras, the wired ones anyway, are constant consumers. Subscription-free cameras like Reolink PoE models draw 4 to 8 watts each when idle, more when recording or streaming. 4 cameras at 6 watts each means 210 kilowatt hours annually. Wireless battery models avoid vampire draw, but shift the energy cost to charging cycles, and replacement batteries every 18 to 24 months create e-waste instead. Smart lighting hubs and bulbs have their own overhead. A Philips Hue bridge draws 2 watts continuously. Each connected bulb draws 0.2 to 0.5 watts when off to maintain mesh connectivity. 20 bulbs at 0.3 watts each adds another 6 watts, or 52 kilowatt hours annually. Zigbee versus Z-Wave bulbs show similar standby behavior. Mesh protocols require always-on radios. Smart plugs themselves consume power. Every smart plug monitoring energy consumes half a watt to 2 watts doing so. If you've installed 30 smart plugs to save energy, you've added 15 to 60 watts of baseline load. That's 130 to 525 kilowatt hours annually before they control a single device. I removed plugs from lamps I manually turn off anyway and saved 8 watts immediately. Chargers and power adapters left plugged in are small individually, but add up. USB wall adapters draw zero point 0.1 to half a watt with nothing connected. Laptop chargers, half a watt to 2 watts. Phone chargers, zero point 0.2 to half a watt. 10 chargers at half a watt average means 44 kilowatt hours annually. Smart or not, unplug them. Entertainment systems and AV receivers can be shockingly wasteful. My Denon AVR 3700H drew 38 watts in standby with HDMI CEC enabled so it could turn on when the TV does. A smart feature. Disabling CEC dropped standby to 0.8 watts. Over a year, that one setting change recovered 325 kilowatt hours, roughly $45. I use Zoo's Z-Wave Plus plugs with real-time monitoring to track everything. Protocol note, Z-Wave uses less power for the plug itself, half a watt to 0.8 watts, than Wi-Fi equivalents at 1.5 to 2.5 watts, but requires a Z-Wave hub that also draws power. For small deployments, Wi-Fi plugs are net lower consumption. For mesh networks of 15-plus devices, Z-Wave or Zigbee wins. Let's look at automation-specific energy waste, when smart makes things worse. Your automations might be costing you money. Here's how to audit the logic itself. Redundant sensor polling is a common trap. If motion sensor state changes, then check all sensor states logic can cause your hub to pull every device every time one changes. On Zigbee networks with 40-plus devices, this creates mesh chatter that keeps radios awake longer than necessary. Check your hub's network traffic logs. If you're seeing constant bind requests or repeated attribute raids, your automations are poorly optimized. I rebuilt mine as event-driven rather than polling-based and reduced average hub load by 30%. Cloud-dependent automations with internet fallback waste power too. If your setup routes commands through AWS or Google servers, even when devices are local capable, you're adding latency and power draw. Your router and hub stay busy maintaining those connections. Local-only automation with Home Assistant eliminates this entirely. My automation response time dropped from 800 milliseconds to 120 milliseconds, and average power draw fell because devices weren't retrying failed cloud handshakes. Occupancy-based lighting that misfires is another culprit. If motion detected, then lights on for 10 minutes seems efficient until you realize your Zigbee motion sensor triggers on pets, shadows, or HVAC airflow. Light cycling on unnecessarily wastes power. Add a lux condition. If motion detected and ambient light is less than 50 lux, then lights on. That one change cut my false positive activations by 70%. Heating and cooling smart schedules that fight each other can be disastrous. I watched a friend's setup run this logic. If temp is less than 68 degrees, then heater on, while simultaneously running if CO2 is greater than 1,000 parts per million, then ventilation fan on, which vented the warm air outside. Both automations were smart. Together, they increased heating runtime by 40%. Audit your conditional logic for conflicts. Time of use rate automations that don't account for battery storage or solar miss the point. If you're running peak and off-peak automations, but you have a home battery or solar system, make sure the logic checks battery state or solar production first. Blindly deferring loads to midnight when your battery is full at 6 p.m. wastes stored energy that would otherwise offset peak usage. The correct logic is if electricity rate equals peak, and battery charge is greater than 80%, or solar production is greater than current load, then defer heavy loads. Else, schedule normally. Device grouping that keeps entire circuits awake is inefficient. Some hubs treat group devices as a single entity. Turning one on sends a command to all. On Zigbee and Thread networks, this keeps every bulb's radio awake even if only one bulb actually illuminated. Use scenes or individual addressing instead. My Philips Hue versus Lutron comparison showed Lutron's zone-based control is 15 to 20% more power efficient at scale because it doesn't broadcast to group devices unnecessarily. Check your automation execution logs. If the same automation is triggering more than 10 times daily, or if you see rapid on-off-on cycles, your logic is wasteful. Now, for something manufacturers won't tell you, the privacy energy paradox, when data collection wastes watts. Cloud-connected devices consume more power because they're phoning home constantly. When I packet sniffed my previous Wi-Fi setup before moving to local-only Zigbee, I found my Ecobee thermostat sending data every 12 to 18 seconds, even when nothing changed. That persistent HTTPS handshaking kept the Wi-Fi radio active continuously instead of allowing sleep cycles. Power draw was 2.8 watts average. After switching to a local-only Z-Wave thermostat with Home Assistant integration, average draw dropped to 1.1 watts. Same functionality, 60% less power, and zero outbound telemetry. Smart speakers are the worst offenders. An Echo Dot doesn't just listen for Alexa, it maintains a persistent WebSocket connection to AWS, uploads wake word clips for cloud processing, and checks for firmware updates every few hours. A HomePod Mini in HomeKit mode, which routes commands through iCloud even for local devices, draws 1.8 watts average. A HomePod Mini in thread-only mode with Home Assistant, 0.9 watts. Cutting the cloud tie literally cut power consumption in half. For most devices, cloud-free viability directly correlates with power efficiency. Devices that can operate entirely on local Zigbee, Z-Wave, or Thread use their radios in brief bursts, then sleep. Wi-Fi devices with cloud dependencies keep radios awake for polling, heartbeats, and usage analytics, read that as surveillance. If you're serious about energy auditing, you need to audit the data flow too. Use Wireshark or GlassWire to monitor your smart home's outbound traffic for 24 hours. Count the packet rate. My previous setup sent 40,000 to 60,000 outbound packets daily from smart devices. My current local-only setup? 0, except when I manually trigger a remote notification. The energy savings are measurable and permanent. Here's your summary smart home energy audit checklist. Print it, check boxes, reclaim your power bill. Measure baseline draw of all hubs, controllers, routers, and NAS devices. If total exceeds 50 watts, consolidate or eliminate redundant hardware. Install energy monitoring smart plugs on all high-draw devices, HVAC controllers, EVs, space heaters, water heaters, and log actual consumption for 2 weeks. Identify every device with phantom draw greater than 1 watt. TVs, AVRs, voice assistants, cameras. Either disable standby features or automate hard power off during unused hours. Count your smart plugs. If you have more than 20, audit whether each one actually serves an automation purpose or is just monitoring for vanity. Review every automation for redundant polling, cloud dependencies, conflicting logic, or grouping behavior that wastes power. Run a packet capture for 24 hours. If you see persistent outbound traffic from devices that should be idle, migrate to local-only alternatives. Check time-of-use automations against your actual solar or battery state. Don't defer loads blindly if you're wasting stored energy. Calculate total annual phantom load. Sum of all standby watts times 8,760 hours divided by 1,000 times your kilowatt-hour rate. If that number exceeds $50, you have low-hanging fruit. My audit found $187 in annual waste from devices doing nothing. Yours will vary, but I've never seen a smart home audit come back clean. Let's hit some frequently asked questions. How much power does a typical smart home consume in standby mode alone? A moderately equipped smart home with 30 to 40 devices, hub, router, mesh nodes, 15 smart bulbs, 10 smart plugs, 4 cameras, 3 voice assistants, smart thermostat, and entertainment system typically consumes 40 to 80 watts in standby. That's 350 to 700 kilowatt hours annually, or $50 to $100 depending on your electricity rate, before a single automation executes or light turns on. Do Zigbee and Z-Wave devices use less standby power than Wi-Fi devices? Yes, but with nuance. Zigbee and Z-Wave devices themselves draw zero point 0.2 to zero point 0.8 watts in standby versus 1.5 to 3 watts for Wi-Fi equivalents, but you must add the hub's 3 to 8 watts continuous draw to your total. Wi-Fi devices use your existing router infrastructure, so for deployments under 10 devices, Wi-Fi may actually be lower net consumption. Beyond that threshold, mesh protocols become more efficient at scale due to lower per-device draw and better sleep modes. Will a smart home energy monitor like Sense or Emporia View pay for itself through savings? Only if you act on the data. The monitor itself consumes 3 to 6 watts continuously, 26 to 52 kilowatt hours annually, and costs $200 to $350 upfront. If your audit reveals and eliminates $100 or more in annual waste, which most do, you'll break even in 2 to 3 years. But if you install it and never review the data or change behavior, you've just added another vampire load to your baseline. The Smart Home Energy Audit Checklist above isn't theoretical. It's the same process I use to cut my own power bill by 18% without sacrificing a single automation. The hard truth is that most smart devices consume more power than their dumb equivalents because they're designed for convenience and data extraction, not efficiency. Start with infrastructure, hubs, and networking. Move to phantom loads, the devices that never sleep. Then audit the logic itself. Automations can waste power just as effectively as hardware. And if you're running a cloud-dependent setup, understand that every packet sent to AWS or Google servers costs you watts. Local control isn't just a privacy win, it's a measurable energy reduction. You'll find waste. Everyone does. The question is whether you're willing to unplug a few conveniences to stop paying for them around the clock. Cloud-free viability score for energy auditing is 10 out of 10. Every tool you need, smart plugs with energy monitoring, home assistance energy dashboard, packet capture tools, works entirely offline. The manufacturers whose devices waste the most power are the same ones desperate to hide consumption data behind cloud portals you can't export from. Local control gives you the raw numbers they don't want you to see. That wraps up this episode of the Smart Home Setup Podcast. Thanks for listening. We'll be back Monday, Wednesday, and Friday with new episodes. If you got something out of this one, leaving a 5-star rating and a quick review really does help. It's how other people who are looking for practical smart home info actually find the show. And if you haven't already, hit subscribe or follow so you get notified the moment a new episode drops. Appreciate you being here. Talk soon.